This is a high-powered amplifier for a UHF television transmitter utilizing an inductive output tube, or IOT. The transmitter was manufactured by TheOLE, now Thomson Grass Valley, but this description basically applies to all IoT transmitters. The first stop is the front panel with its indicators and controls. The large LCD readout is used to display information for the engineer regarding hours in operation, number of crowbars fired, and a history of the past 100 events. It is also used to adjust the bias and heater voltages of the IoT. Above the LCD are the primary controls for the transmitter. Under each of the three mode buttons is a set of lights that indicate if the transmitter is ready to proceed to the next operational mode. Below all this is the high voltage interlock system, designed to prevent an engineer from coming in contact with any high voltage. The keys are used to prevent any compartments from being opened before they are grounded by actuating the grounding lever. The IoT compartment contains the inductive output tube and its associated parts. The signal that is to be amplified is applied to the input cavity via a heliax cable at a power level of 100 to 400 watts. The input cavity is tuned by mechanical adjustment via a rotating crank, and its position is registered on this mechanical display. The IoT uses several tuned cavities to amplify the signal applied to it. These are the input cavity and the first and second output cavities, as well as the coupling adjustment between them. There is also the output coupling to the transmission line. These controls are adjusted for the desired channel. And here is the dial indicator for the first output cavity, and over here for the second output cavity. This is the indicator for the coupling between the two, and over here, this is the indicator for the amount of coupling to the output transmission line. RF probes are used to sample the signal, and the amount of signal attenuation is labeled on the probes themselves. Cooling air is applied to the output stack to keep it from overheating. At the rear of the IoT cabinet are the IPAs, or intermediate power amplifiers, which are used to amplify the signal from the exciter to a level required by the IoT. Several solid-state amplifiers are needed, and the outputs are combined here and monitored with a directional coupler. An RF switch is used to make sure that all RF is off, going to the IPAs when maintenance is performed. Cooling of the IoT is monitored here, where the temperature and flow of the coolant can be observed as it returns from the IoT. On the back wall behind the transmitter is the plumbing system for the coolant. Pipes from the heat exchanger on the roof come down and are distributed to the HPAs and the dummy load. The flow of coolant to the dummy load is monitored precisely in order to perform power calibrations on the transmitter. All of the external systems are connected to this control unit, which in turn is connected to the transmitter. The unit above it is used to communicate with the combiner room's RF system on the roof. The 480-volt three-phase power that is used by the transmitter comes in through these fused disconnect switches. The output of the transmitter goes through a coax harmonic filter and then to a waffle iron filter to attenuate the harmonics even more. The tuners are used to match the waveguide to the coax transmission line in order to maximize the power transfer. After the transition from waveguide to coax. The transmission line carrying the output of the HPA travels through the transmitter room and down the hall, where after several more elbows, tuners are required in order to match the impedance of the line. The transmission line must be pressurized in order to keep it clean and dry. Here, the pressure and flow of nitrogen is monitored. The heat exchanger on the roof utilizes a tank to hold the coolant and a radiator with several fans to cool it before it returns to the transmitter. Most systems use 2 water pumps to avoid a shutdown in case one fails. The fans turn on as needed for the amount of cooling required. In the combiner room, the RF from the HPA is connected to the mask filter, which is made up of several large tuned cavities that assist in the removal of unwanted portions of the signal. After the signals from several stations are combined, they are monitored from stacks like this one. Next, the combined signals are transported up the tower to the community antenna. These 4 transmission lines connect the 11 stations that are on this tower.